All right, the next thing we're going to learn about is called changing an attribute of a rectangular prism. All right, changing an attribute means if we change the length or we change the width or the height. All right, each of those is called an attribute. So what we're going to do is we need to go to this website. All right, it should be under announcement on your Blackboard, or what you can do, all right, just type in Shodor and then surface area and volume. Shodor, surface area and volume. And it will be this first one. Okay. Now, we have a rectangular prism here. To follow along with this, we're going to have our original prism has a width of 2, a length, which they call the depth, 6, and the height is 4. So the width is 2, the length is 6, the height is 4. We need to change that on our prism. So if you scroll down, they want the width to be 2, the depth to be, which is the length, to be 6, right? Yep, and then the height is 4. Now, what's really neat is if you look over here, it tells us the volume of this rectangular prism and its surface area. Okay, it gives us the volume and the surface area. So we go back over here and we're going to write that in. The volume was 48, the surface area is 88. So volume is 48 and the surface area is 88. This is going to be our original. Now we're going to start changing one attribute and we'll leave the other two the same. So on this first one, we're only going to change the width. So we want to multiply the width by 2. The original width is 2, so if we multiply it by 2, what will my new width be? Yeah, it's going to be 4. So what we're going to do now is we're going to go back, we're going to change the width to 4 and write down our new volume and our new surface area. All right, the new volume is 96 and the surface area is 128. So 96 and 128. All right, next, instead of changing the width, this time they only want us to change the length of the original. So the width will be 2 again. We're going to leave the height at 4 and we want to change the original length of 6, multiply it by 2. So what will the new length be? Yeah, it's going to be 12. So we're going to go ahead and have the length be 2, or the width 2 by 12 by 4. 2, 12, and 4. So let's go back. 2, 12, and 4. Let's go ahead, look at the volume and the surface area. The volume is 96, surface area is 160. 96 and 160. All right, last, they want us to only change the height now. Multiply the height by 2 of this original prism. So we're back to the width being 2, the length 6, and now the height, instead of the original 4, multiply by 2, we get 8. And then we're going to go ahead and find our new volume and surface area of that prism. So 2, 6, 8. So 2. This needs to go back to 6 and then 8. So we have 96 and 152. So 96 and 152. All right, looking at this, let's look at this for a minute. So on this one, we multiplied the width by 2. We left the others the same. Notice that the volume changed to this, the surface area changed to this. Both of them got bigger from the original. When we multiply just the length by 2, again, both of them got bigger than the original. Same thing with the height. both of them got bigger. They both got bigger. They increased from the original. But do you notice how the volume is the same on all three? So whether we multiplied the width by 2 or the length or the height, the volume increased. Whoops, that's my alarm. The volume increased to the same thing. Now, what I want you guys to see, it increased by a very, very specific amount. All right, watch this. 48 times 2 is 96. So when we multiplied the width by 2, the volume got multiplied by 2. When we multiplied the length by 2, the original volume got multiplied by 2. And same thing when we did it to the height. Did that happen for surface area? Well, let's take a look. Where's my calculator? There it is. Let's look. So the original surface area is 88. 88 times 2. No, that did not work. So it only worked for volume. So now they ask, compare the volume of the original prism to the volume of the new prism. Explain how multiplying any of them by 2 affected the original volume. Well, we should realize that what it did was it multiplied the volume by 2 also. Okay? So when we multiplied one of them by 2, the volume got multiplied by 2. All right? Compare the surface area of the original with the new prisms. How did that affect it? Well, guys, did it get multiplied by 2? No. All we can say about that was it increased. It increased by different amounts. Okay? Then it says, predict what would happen if you tripled one of the attributes. All right, well, I will let you go ahead and come up with your own prediction, and then you're going to go ahead and do number 4 using the thing on your own. Something that I want you to do real quick. So do number 4, all right, and then you are going to do the back, and you are going to go up to, once you finish this part, okay, I want you to go ahead and pause the video, okay, and I'm going to explain or go over this a little bit, okay, so go ahead and do number 4, get that for me, and then do this table, and then we're going to talk some more. All right, welcome back. This is what you should have gotten for number 4. Now notice, when we tripled just the width, let's look at the original volume. The original volume was 48. So here's my calculator. It was 48. I multiplied the width by 3. Now watch what happens when I multiply the original volume by 3. So times 3, I got 144. And now look, do you see how when I multiplied each separate thing by 3, we got 144 each time. We multiplied the length by 3. All right, the original length was 6 times 3 gives us 18. The volume got multiplied by 3. Same thing when we multiplied the height by 3. The volume got multiplied by 3. But now for surface area, is that true? Well, let's take a look. 88 times 3. Nope. So all that happened with the surface area was it got bigger, but by different amounts. However, the volume got multiplied by 3. Now the reason why that works, let's take a look at a picture. Look at this coffee mug. Let's say that I want to drink out of this coffee mug. All right. Think about how much coffee it can hold. That's volume. How much coffee it can hold. Now, if I multiply the height by 2, if I basically double this, if I make it twice as high, think about how much more coffee I can hold. I'm going to be able to hold twice as much coffee. If I double the height, we can fit twice as much coffee in there. Does that make sense? If I triple the height, we're going to be able to hold triple the amount of coffee. But now going back to if I doubled this, okay? Or we'll get to that, what I was about to talk to on the tissue boxes. Let's look at tissue boxes next. So looking here, all right? Let's say, all right, that's a bad picture. Let's look at, nope. Ah, darn it. I thought I had a picture. All right, let's look at this picture. So look at this one tissue box. That's my original. If we multiplied the height by 3, it would go we would now have 3 of them. So now we can hold, the tissues that we can hold is the volume. I can hold 3 times as many tissues. If in this box there's 100 tissues, but we multiply the height by 3, now we can hold 300 tissues. We can hold 3 times as many tissues. But that's not going to be true for surface area, and the reason why. If we created a really, really tall tissue box, imagine this is one tissue box, it would only have the cardboard. Surface area is the cardboard. The cardboard would be on the bottom, on the top, one piece over here, one piece over here, one piece on the front, and one piece on the back. So we would lose the cardboard that was originally on the top and bottom of these other pieces. We would lose that, okay? There would be no cardboard there because it would be one gigantic tissue box. So the cardboard does not triple, okay? Only what's inside is going to triple. Does that make sense? Oh, that's not a good picture. Let's see what we have. And yeah, I don't know what's left. None of these are good. Oh wait, I have one other one. Here's another picture. So same thing. If let's only look at these two. If I doubled the width, then they would get put together the way we're looking at them. And now we can hold twice as many tissues. If there are 50 tissues in the original, now we can hold 100. If, let's say, there were 70 tissues, now we can hold 140. So again, the inside doubles, but the cardboard will not double, what's on the outside. Because if it were smushed together and the tissues were going long like this, we would have cardboard in the front, in the back, on the top, on the bottom, on this side, and on that side. We would not need cardboard right here because they would be connected. So the cardboard does not double. Surface area will just get bigger, but the volume will get multiplied by 2. So if you look on this last one, this is what you should have gotten when we multiplied by a half. So if we take half of the original width, think about what will happen to the volume. All right. If my coffee mug, if it's only halfway filled, or if I cut this mug in half, I'm only going to be able to hold half the volume, half the amount of coffee. Okay, so going back to this, if we cut it in half, multiply by 0.5 or half, or divide by 2, the volume gets divided by 2. All right, if I cut the length in half, I divided by 2, the volume got cut in 2. It got multiplied by a half, or you can think of it as divided by 2. Same thing here, the height got split in 2, so did the volume. All right, looking at the surface area, all we can say here is that it decreased. So here, the volume also got multiplied by 1/2 or divided by 2. You can think of it either way. And the surface area, all that we can say about that one is that it decreased different amounts. Okay? If you still don't understand my visuals on this, with the tissue boxes and all that, I can show you in person. Just ask me and I will explain. Go ahead and do 7, 8, and 9. Do those questions. When you're done, get checked. Good luck. You got this.